types of microscope will have different type of lenses. But what they all have in common is that they have eyepiece lens and objective lenses. Eyepiece lens, in this case, in compound light microscope, will be 10 times. This 10 times means that the lens has magnification of 10 times. Different types of microscopes regarding eyepiece lens can have between 5 to 30 times the lens. Regarding objective lenses, in this specific type compound light microscope, they have 3 different lenses or 3 different objectives. The smallest one that you can see on the left side is basically scanning power, which has magnification 4 times. Then the middle one has a low power and has 10 times. And the biggest one or the largest one has high power or 40 times. Again, different types of microscopes can have different kinds of objective lenses. How to calculate the total magnification of the microscope? So that you can actually calculate this, you need to have 2 main informations. So the first one, you need to know how much is the eyepiece lens magnification. Like we mentioned before, the light compound microscope has 10 times. So in this case, now in this example that we will calculate, we will use that eyepiece lens has magnification 10 times. The second information that you need is which objective lens are you using in that specific moment when you are performing experiment. So in this case on the slide, you can see that we are using small magnification or 4 times. Now, when you have these main 2 informations, how you can actually calculate total magnification? So you just need to multiply the number of eyepiece lens, in our case this is 10 times, with the number of objective lens that you're using in the experiment, in this case is 4 times. So in the end, the number that you get is total magnification number, which is meaning 10 times 4 is 40 times. So the total magnification in this case is 40 times. How do you calculate the image size of a microscope? So let's say, for example, bacteria. Bacteria you cannot see with your naked eye, so you need a microscope. And if you cannot see it with your naked eye, you are not able to calculate the bacteria's length using just, let's say, a ruler. So what actually we can do? You put bacteria under the microscope, you use specific kind of total magnification. So like in previous task, we had the eyepiece lens was 10 times, and we used the low power, which was scanning, basically was 4 times, so altogether was 40 times total magnification. So the information that you have, that you use for the microscope, is the total magnification is, let's say, 40. Then you observe under the microscope using this total magnification, and you see something. The thing that you see is bacteria. And actually, that image that you get under the microscope, you can actually measure. And you measure it, and you get that the size of the image that you observe under the microscope is 80 micrometers. So the next step, what you can do. So you already have 2 informations. One is that the size of bacteria under the microscope is 80 micrometers, and you have that the total magnification is 40 times. So how you can actually calculate the actual length of the bacteria? So you need to divide the length of the image that you get under the microscope with the magnification. So in our case, that was 80 micrometers divided by 40, which is 2 micrometers. So the actual length of bacteria is 2 micrometers.